Hello students, once again welcome to your favorite channel TKG Physics classes. And students, all of you know our ongoing chapter name, that is laws of motion, your chapter number 5, and we just completed one lecture from laws of motion. And what we learned from that lecture? We learned the basic thing. We learned the inertia. We learned inertia of rest, inertia of motion, inertia in direction. Then we learned Newton's laws of motion, first law, second law and third law. And we learned about linear momentum. Now today, this is our lecture number 2 for your laws of motion chapter. And in this lecture, we will discuss, you see, the title, that is impulsive force, and there is impulse. Today we will discuss impulse and impulsive force. So students, do you know the meaning of impulse and impulsive force? When a large amount of force, large amount of force, the magnitude value of force is large, is imparted on a body, is applied on a body, very short time interval. When a large amount of force imparted on a body in a short time interval, the time interval that is very short and the magnitude of force that is very large, then the product of force and this time interval, product of force and the time interval during which the force act on the body is called impulse. And this large amount of force is named as impulsive force. You see the definition of impulsive force. Here you see a large force acting for a short time to produce a finite change in momentum is called impulsive force. A large amount of force which produce a finite change in momentum. How? You see, suppose this is a body of mass m moving with initial velocity u. So what is the linear momentum? P1, that is equal to m into u. Okay, now you applying a large amount of force on that body. This force value is large. So obviously when you apply a large amount of force, this body's velocity will increases. Yes or not? You applying a force on a body, so its velocity is increases. So its linear momentum, final linear momentum will be m into v. Suppose its final velocity v. So its velocity changes, you see, produce a finite change in momentum. So when velocity changes, its momentum also changes. You see, change in momentum, that is p2 minus p1, mv minus mu. So this is the definition of impulsive force. Now, what is the example of impulsive force? All of you know, you see, the force exerted by a bat while hitting a ball. When a cricketer hits a ball, you just imagine large amount of force applied on that ball. But the time taken, the time impact is very small. The time interval is very small. But the large amount of force is applied on that ball. And the ball goes outside of the boundary. So this is an example of impulsive force. And you see second one, force experienced by a person when he falls from a certain height on a marble road. You don't need to imagine this one, okay, don't try it. You just see, when a person fall on a marble floor from a certain height, the force exerted on that body, on that person, is very large, but the time taken, the time interval, that is very small. So this is an example of impulsive force. So impulsive force, that means large amount of force which is applied in a very small time interval. Okay, now what is the impulse of force? So impulse, that means, you see the definition, write down, impulse is the total effect of large force when acts for a short time to produce a finite change in momentum. That means impulse is the product of force and time duration. The time duration in which the force acts on the body. So the product of force and time duration is known as impulse, and the large amount of force is known as impulsive force. You know, the impulse is denoted by symbol J. Impulse is denoted by symbol J. Denoted by symbol J, and their force F and time interval, suppose T2 minus of T1, which is named as del T. J vector, you write it here in vector form. J impulse is a vector quantity, force is a vector, F, and T2 minus T1, this is del T. Okay, so this is the expression of impulse. Now what is the unit and dimension of impulse? You can easily find out with the help of this formula. Find it. Okay, for SI unit, write it. SI unit, force SI unit Newton, and time SI unit, that is second. So Newton second, you can write Newton second, or you can also explain this Newton. Force, that is mass into acceleration, so in the place of Newton you can write kg meter per second, second square. So second cancel out, so this one is kg meter per second. This is the SI unit. And now write CGS unit. CGS unit, that is force m into a, m that is gram, and a, that means centimeter per second square, and time, that is second. So second cancel out, so this one will be gram centimeter second minus of 1. So this is the SI unit and this is the CGS unit. Now write down the dimension. You use the dimension of force, impulse dimension, that is force dimension mLt minus 2, and the time dimension, that is t. So the dimension of impulse will be, you see, m l t minus 2, that is plus 1. So this one will be t to the power minus 1. Okay. So this is the basic part. This is the definition of impulse. Now we prove that impulse is a product of force and time interval using integration. Okay, write it. Impulse, you can take a screenshot this one. So you write impulse is a product of force and time interval. Impulse is product of force and time interval. Suppose a force capital F vector is act on a body in time dt, then impulse is written as, okay, impulse is given by dj. Why dj? You see, the impulse act on a body for a short time interval dt. So in general, impulse is represented by j, and for small value that is represented as dj. So dj is equal to f into dt. Now the total impulse. Now for finite time, for time interval t1 to t2, the total impulse is j vector, and it is represented by integration. It is found integrating by integrating dj. That means you have to integrate this one, integration f into dt vector, that is j vector is equal to f into dt vector. And you see here integration, dj integration, so this is g, and limit t1 to t2. Now you see here f and dt, f is constant or variable. Sometimes it is constant and sometimes it is variable, but in general condition, in the place of f we use the average value of force. Question is, why we use average value of force? Suppose a ball is hitting on this wall. You just imagine a ball is hitting on this wall. So when the ball is placed here, there is no force applied on that wall, so force is 0. Now ball is going this way, at just when the ball just hitting this wall, the force applied and force value is increases, the magnitude value of force is increases. Now when the ball return back, the magnitude value of force is decreases. So initially force 0, when the ball hits the wall, force applied and it's returned back, then the force becomes decreases. So in general here we use the average value of force. So here this force must be average force, and this is constant part, so this part will be outside. When you take average, so this one will be constant, T1 to T2, and there is a dt. Now you see F average and dt integration, that is t, so this one is T1 to T2. Now you just use the limit F average, here this one is T2 minus of T1, so this one is F average and T2 minus T1, that is del t. So J vector is equal to F into del t. J is named as impulse, J is named as impulse, F is the average force into time duration. Okay, so this is the product, that is average force into time duration, which gives impulse. Now we will discuss impulse momentum theorem. You just observe the name, impulse momentum theorem. That means the impulse by force, the impulse of a force is exactly equal to, impulse momentum is exactly equal to change in momentum of that body. Okay, write it, impulse momentum theorem. So our next topic, it is impulse momentum theorem. Then after that we will learn how to calculate impulse by graphical method. So first of all, now you write impulse momentum theorem. Impulse momentum theorem, and this theorem will be proved. At first you prove this one with the help of Newton's second law. From Newton's second law, we can write F vector, that is equal to dp by dt. Yes, the rate of change of momentum is directly proportional to force and the direction is same. Okay, so from here you can easily write F vector into dt, that is equal to dp vector. Now for time interval 0 to t, suppose momentum changes from p1, that means at time 0 momentum is p1, to when time t momentum is p2. Okay, then and integrate this above equation and integrate, we can write it, this one, integration f dt, that is equal to integration dp. Now you see here integration with respect to dt, so time lower limit 0, upper limit t, and here integration lower limit, that is p1, and upper limit, that is p2. Now this one must be f average outside, and this integration dt, that means t1 to t2, and dp integration, that means p, and there is limit p1 to p2. Now just putting the limit, f average into t2 minus of t1, that is equal to p2 vector minus of p1 vector. So this one will be f average t2 minus t1, that is del t, that is equal to p2 vector minus of p1 vector. So this one is named as impulse, f into del t, the product of force into time interval, impulse. So J is equal to p2 vector minus of p1 vector. This one, you see, impulse of a body is exactly equal to the change in momentum of that body. So this is the statement, write it. The impulse momentum theorem states that the impulse of a force act on a body is equal to the change in momentum of that body. So this is the impulse momentum theorem, and you see there is a various application of impulse momentum theorem in our daily life. You know how to catch a cricket ball? Okay, at first this is the way out for catching a cricket ball. Your hand is fixed, and there is another way, that is you catch a cricket ball like this way, What is the proper method? Proper method is this one. You have to catch a cricket ball like this way. Your hand will be going downward. Question is why? What is the advantage of it? You see, according to this theorem, if this one is constant, if this momentum change is constant, then dt f is inversely proportional to dt. That means when time is increases, when the time interval is increases, corresponding force applied on the body, force imparted on the body is decreases. That means, you see, when you applying this one like this way, that means your time interval is increases for taking a catch. When time interval increases, the force imparted by the ball on your hand is decreases. So that's why we use this method, not like this way. Okay, so this is the application of impulse momentum theorem. Okay, now we'll show graphical method. We'll show graphical method how to find out impulse by graph, when a constant force applied on a body and when a variable force applied on a body. Then we'll solve some numericals. Okay, so write it. Now we'll check how to find out impulse by graphical method. Write it down, students. So our first point, impulse by graphical method. Graphical method. And our first condition, when a constant force applied on a body. When a constant force is applied. When a constant force is applied. So at first you draw the graph. You see, this is a time axis, this is x-axis is represented by time, and y-axis is represented by force. Force in CJ system Newton, time in CJ system unit is second. Now a constant force is applied for our first condition. That means time increases with the passage of time, the magnitude value of force remains constant. So what will be the graph? You see, time increases but the force value remains constant. So this is the graph. You see, when time t1, suppose this time is t1, the corresponding force is this one. This value is the force, this is the value at time t1. Now time increases but the magnitude value of force, this c, magnitude value of force constant, and you see this is our final time, which is named as t2. You named it a, b, this point is c and this point is d. Now you just observe the graph under AB straight line. What is represented? The area. You see the area under AB. The area under AB. That means the area of this rectangle. Now write down the area of FT graph. Now find out area of FT graph. That means area of rectangle ABCD. Area of rectangle ABCD. Now you know the formula, rectangle area, length into breadth, length into breadth. So length, that means you can write DC and you can write AB also, write it AB, and breadth, that is AD, or you can write BC, you write AD. Now you just observe what is the value of AB. A correspond to time t1, B correspond to time t2. So AB, that means t2 minus of t1. And what is the value of AD? D point correspond to 0, this is the origin, and A point correspond to force F, this is the force F, constant force. So this one is represent F. So F, and this one is represent del T, and you know the meaning of F into del T. F into del T, that means impulse. So from this graph we can prove that if we find out the area under this ft graph, the area under force time graph, the result will be the impulse of that body. So this is the condition when a constant force is applied. Now question is, when a variable force is applied on a body, how to find out impulse? There is no condition always constant force applied on a body. It may be variable. So our second condition, write it, when a variable force applied, for variable force, now you see, for variable force the graph will be like this way. Suppose this point is t1, this point is t2. You see, this is the time axis, this is the force, y axis represent force, this is in Newton, this is in second. Now you see, at time t1 the force is this one. When time increases, for this time you see the magnitude value of force also changes. Now at that time you see magnitude value of force is decreases. So with the passage of time the magnitude value of force varies here. So question is, how to find out the impulse here? So for finding impulse here, you have to consider, you just consider a small strip. You see, you consider a small strip. Now you just find out the area of this strip. It looks like rectangle. This point A, this point B, this point C, and this point D. Suppose DC, that is the time interval which is named as dt, and you see the point A and point B is exactly same. So when we find out the average between A and B, this point is represent the force point A, and B point correspond the force here, nearly equal. So the average will be remains constant like this way. So area of ft graph for variable force, that means at first you find out the area of strip A, B, C, D. Area of strip A, B, C, D, and this one will be, you see, this length, that is dt, and this length, that is force. So this one will be F into dt, and this is the area, this is the impulse for this region. Now question is, how to find out the total impulse? So for finding total impulse, you know, F into del t, that is impulse. So for finding total impulse, okay, you write it, this one is dj. Okay, so total impulse J will be integration of dj, and integration of dj, that means you know the limit here, lower limit, that is t1, initial time interval, and final time interval t2. So this one will be t1 to t2, that is t1 to t2 f into dt. So for when a variable force applied on a body, we have to integrate with this total time interval, and when a constant force is applied, you just simply calculate the area under this ft graph, then you can easily find out the impulse of that body. Okay, I think this part is clear to all of you. Now we will solve some numericals, students. Okay, now see problem 1. In problem 1, given a cricket ball of mass 150 gram, write it, first value given, that is mass. So problem 1, mass given 150 grams, so you convert it in kg, so this one will be 0.15 kg, moving with a velocity of 15 meter per second. So this one is the initial velocity, value given 15 meter per second, is brought to rest. Finally it at rest, so that is final velocity v is equal to 0 by a player in t equal to, time given t equal to 0.05 second. Calculate the impulse. You have to find out the value of j and the average force F. Okay, so you know the value of m, u, and v, and you have to find out the value of impulse, and we know the impulse momentum theorem, that is impulse is equal to change in momentum. So write it, according to impulse momentum theorem, that is impulse j is equal to del p, that is j is equal to mv minus of mu, that is j is equal to mv minus of u. Now putting the value m 0.15, v0 minus u which one, that is minus 15. So this value is minus 225, so 225 divided by 100, that is this value minus 2.25, and the unit is impulse, that is force into time, that is Newton second. Okay, now force, that means impulse into time duration, that is impulse equal to force into time duration. So that is impulse minus 2.25 and time duration 0.05, cancel out 5 4, this is 45 minus 45 Newton. And you know the meaning of this negative sign? Here negative sign indicates the retarding nature of force. Okay, so in this way you can solve problem 1. Now see problem 2. While launching a rocket of mass 2 into 10 to the power 4, first of all you write the given value, which value given and which value you have to find out. Then you find the equation for finding this value. So now problem 2. In problem 2, mass given, that is which value, 2 into 10 to the power 4 kg. Force F given, that is 5 into 10 to the power 5 Newton, is applied for 20 seconds. Time given, applied for 20 seconds. Calculate the velocity attained by the rocket. That means you have to calculate final velocity at the end of t equal to 20 seconds. So obviously initial velocity is 0. Okay. So, and you have to find out the velocity of v, that is final velocity. Mass given, force given, time given, u0, v find out. So use impulse momentum theorem. J, that is equal to mv minus u, and in the place of j you write f into del t, because f and time both are given. Now putting the value, f 5 into 10 to the power 5, del t, that is 20, mass, that is 2 into 10 to the power 4, v you have to find out, and u0. So from here v will be 5 into 10 to the power 5 into 20 divided by 2 into 10 to the power 4. Now solve it. This one is 10, this 10, 10 to the power 3, so this one is 10 to the power 3, 10 to the power 3, 10 to the power 5, that is 10 to the power 2. So v, that is equal to 5 into 10 to the power 2, that is 500 meter per second. Okay, so the final velocity attained by the rocket, that is 500 meter per second. And in general you have to calculate these types of formula basically by graphical method. You read it. A graph given, force time graph for a baseball given, and you have to calculate first condition impulse, second condition force exerted on the ball, and the third condition, that is the maximum force on the ball. And you know by graphical method how to find out impulse. You have to find out the area of that graph. So for finding impulse you have to find out the area of this triangle. Okay, find it. So in problem 3, for finding impulse you have to find out area. Problem 3, impulse, that is equal to area of triangle. Suppose this one is point A, this point B, and this point C. A, B, C. Okay. And area of triangle, that is impulse, equal to half into base into height. Now putting the value, j is equal to half. Value of base, you see the point A is marked 1 and C marked 2.5. This one is 1 second, this one is 2.5. So this interval obviously 2.5 minus 1, and the height, you see the height, this is the height, the height value given 18000. Now you can solve this one. This one will be the impulse unit, that is a Newton second. Okay, now you see second one, force exerted on the ball. When you know impulse, when you know time interval, time duration, you can easily find out force by the formula of impulse. Impulse J is equal to F into del T. So force F is equal to J divided by del T. You find the value of J, then putting this value here, and you know the value of del T, 2.5 minus 1, that is 1.5. So at first you find the value of J, put here, and you put the value of del T, then you can easily find out the value of force which exerted on the ball. And the last one, the maximum force. By graph you can easily find out the maximum force. You see, this force is the maximum force. So our third answer, that is maximum force 18,000 Newton. Okay, so in this way you can solve these types of problems, students. Now go back to your exercise book and solve it. Today I'm ending here. I think this part is clear to all of you. If there is any doubt, tell me in the comment section, and if this video is helpful, please share and subscribe this channel. Okay, so today I'm ending here. Still then, meet you soon next class. Still then, bye bye.